For 7 decades, American aircraft carriers went wherever they wanted on the globe. If a crisis broke out anywhere, the first question Washington asked was simple: where are the carriers? Those floating air bases projected American power across every ocean on Earth, and nobody had a real answer to them. But behind closed doors, one nation spent 3 decades working on a quiet project. The goal was not to compete with American carriers. The goal was to make them irrelevant. That nation is China, and today that project is finished. China now fields an entire family of weapons built to do what nobody thought possible: render the most powerful navy in history obsolete. Some of these systems scream in at 10 times the speed of sound. Others dive from the edge of space onto moving ships. Some do not even require a human operator. And the most important one on this list is not a weapon at all. If you are getting something out of these videos, please take a second to hit the like button, because putting these together takes a massive amount of work. And subscribe so you do not miss the next one. We are counting down 7 Chinese systems that reshape the balance of power in the Pacific. Number 7 is already remarkable. But by the time we hit number 1, you will see exactly why military planners are rethinking everything they thought they knew. Let us begin. Number 7. The DF-27. The DF-27 is a missile that can strike the continental United States, and the American defense network was not built to handle it. The Pentagon confirmed in its latest China military assessment that this weapon is already in the field, not sitting in a lab, not undergoing trials. Deployed, operational, and ready for launch. What sets the DF-27 apart is the payload it carries. Sitting on top of the missile is a hypersonic glide vehicle. After the main rocket boosts it high into the atmosphere, this vehicle separates and begins a gliding descent toward its target. But it does not follow a gentle, predictable curve. Instead, it shifts direction constantly. It banks left, then right. It loses altitude, then climbs back up. Picture a stone skipping across a pond, except the stone is traveling at mind-bending speed and can change its own path at any moment. American missile defense architecture, which cost hundreds of billions of dollars to build, relies on predicting where an incoming threat will be. Traditional ballistic missiles fly in an arc that you can calculate. You know the launch point, you know the trajectory, and you know roughly where it will land. You send an interceptor to that spot. The DF-27 breaks that model completely. By the time your computers figure out where it is heading, the vehicle has already adjusted course, making interception nearly impossible with current systems. The reach of this missile is staggering. Its range is 8,000 kilometers. For context, the distance from eastern China to Hawaii is approximately 8,000 kilometers. That puts Seattle, Alaska, and major American military installations throughout the Pacific directly in its path. Nothing on the US West Coast is out of range. And then there is the dual-role design. The DF-27 can carry a nuclear payload, giving it the ability to level a city. But it can also carry a conventional warhead designed to track and destroy a moving aircraft carrier on the open ocean. Same launcher, same missile body. 2 wildly different targets. One configuration can wipe out a city. The other can eliminate a $13 billion carrier strike group. China keeps both options available. The Pacific Ocean used to be a buffer that kept America safe from threats across the water. The DF-27 erased that buffer, and it is only the opening entry on this list. The next system was forged from a searing moment of embarrassment that rewired China's entire military thinking. Number 6. The DF-21D. The story of the DF-21D begins with a wound. In 1996, tensions between China and Taiwan reached a boiling point, and the United States responded by sending 2 complete carrier strike groups through the Taiwan Strait. These massive formations sailed right past China's coastline, a display of naval dominance that Beijing could not answer. China had nothing in its arsenal that could touch those carriers. They could only watch. That event burned itself into China's strategic memory. Military leaders in Beijing described it as a humiliation unlike anything in modern Chinese history. From that day forward, they funneled resources, scientists, and decades of development into creating a direct response. The result was the DF-21D, the first ballistic missile ever built to do something that sounded impossible: track and destroy a moving aircraft carrier at sea. Standard ballistic missiles work against fixed targets. You give the missile a set of coordinates for a building or a runway, it launches, arcs through space, and comes down on that spot. The target does not move, so the math is simple. The DF-21D faces a completely different challenge. A carrier is a moving target. It travels at 30 knots. It can change direction. It can take evasive action. To solve this, Chinese engineers placed a maneuvering re-entry vehicle on top of the missile. Think of it as a warhead, with its own guidance system and small control surfaces. As the warhead plummets back through the atmosphere from the edge of space, it is not just falling blindly. It is receiving updated information about the carrier's position and adjusting its flight path in real time. Imagine taking a dart and throwing it straight up in the air over a moving car. Now imagine that dart has eyes and wings and can steer itself downward to land exactly on the hood of that car as it tries to swerve away. That is what this warhead does. The missile has a range of 1,500 kilometers, and Chinese forces have deployed it in significant numbers along their eastern coast, all aimed at the Pacific. What grabs the attention of military analysts worldwide is the lack of any verified intercept. Nobody has demonstrated, in any realistic combat scenario, that they can shoot this thing down. American defenses have been tested against standard ballistic threats, but a warhead that maneuvers during its final approach is a fundamentally different challenge. China took 30 years of frustration and converted it into a working weapon. But the DF-21D was just the opening move. The next system on this list takes the same concept and makes it mobile. Number 5. The YJ-20. In late 2025, Chinese state media released footage that made defense analysts around the world pause. The video showed a YJ-20 hypersonic anti-ship missile launching from a surface warship in open water. This was not a test from a land facility. It was not fired from a submarine. It came off a regular surface combatant sailing the ocean. That distinction changes everything about how this weapon works in practice. A land-based missile battery sits in a fixed location. You can identify it on satellite imagery, track it, and plan around it. But a missile mounted on a warship can be anywhere. It can move with a fleet. It can loiter among civilian cargo vessels. It can appear on your radar without any warning. The YJ-20 transformed a stationary threat into a roving one. The missile itself flies at hypersonic velocity, which means it travels faster than 5 times the speed of sound. But the real problem is not the speed, it is the attack profile. Most anti-ship missiles approach their target on a relatively flat trajectory, flying low over the water. This gives the targeted ship a window of time to detect the incoming threat, track it, and launch countermeasures. The YJ-20 does something different. As it nears its target, it pulls up sharply, gains altitude, and then plunges almost straight down onto the ship from directly above. Think about how a warship is built. Its defensive systems are aimed outward. Phalanx guns, interceptor launchers, electronic jamming arrays, all of them are designed to engage threats coming from the side or at shallow angles. The armor and the weapons face the horizon. Now think about a medieval fortress with thick walls and archers positioned along the battlements. Those walls are formidable against an army charging at the gate. But if somebody drops a boulder from directly overhead, the walls are meaningless. The YJ-20 is that boulder. For an aircraft carrier, this is devastating. The flight deck is the most critical part of the entire ship. Without a functioning deck, aircraft cannot take off or land. Without aircraft, the carrier loses its entire reason for existing. A $13 billion ship becomes a floating target with no offensive capability. The YJ-20 was engineered to crack that flight deck in a single hit. And because these missiles now ride on surface ships, China can launch several of them at once from different vessels. A carrier group could find itself tracking a dozen inbound YJ-20s arriving from multiple bearings simultaneously. The numbers do not favor the defender, but the YJ-20 is still a single missile. The next entry on our list can reach even further, all the way to one of America's most vital outposts. Number 4. The DF-26. Some weapons earn nicknames through reputation. The DF-26 earned its nickname through pure geography. It is called the Guam Killer because it can reach Guam from the Chinese mainland, a distance of more than 4,000 kilometers. Guam is a U.S. territory in the Western Pacific, and it hosts Andersen Air Force Base and Naval Base Guam. These two installations are the backbone of American military operations in the entire Asia-Pacific region. If you took Guam off the map, American power projection in the Western Pacific would lose its most important anchor. But the DF-26 does not just hit fixed bases. It is also engineered to track and engage moving carriers on the open ocean. That makes it one of the rarest types of weapons on Earth, a missile that can bomb a building and hunt a ship, depending on how it is armed. And the arming question is, what makes this weapon so destabilizing? The DF-26 is nuclear capable. China can load it with a conventional warhead for a precision strike, or it can equip it with a nuclear payload. The problem is that the launch looks identical either way. When this missile leaves its silo, American satellites and radar pick it up immediately. But nobody on the receiving end can tell which type of warhead is sitting on top. Is it conventional? Is it nuclear? You have a handful of minutes to figure it out, and the consequences of guessing wrong are catastrophic. Picture somebody throwing an object at you from across a field. It could be a baseball, or it could be a grenade. You cannot tell until it lands. That uncertainty forces hesitation, and hesitation in a military crisis can be decisive. The broader effect of the DF-26 is that it redrew the map of the Pacific. For decades, American carriers operated under the assumption that if they stayed far enough from China's coast, they were safe. The DF-26 kept pushing that boundary outward. First, it pushed them past the first island chain. Then it pushed them past the second. Now there is no position in the Western Pacific where a carrier can park and feel confident it is out of range. The carriers have been shoved so far back that their own aircraft cannot reach their assigned targets without aerial refueling that may not be available in a combat zone. China did not need to outfight the carrier. It just needed to outrange it. If your planes cannot fly far enough to matter, your carrier is a $13 billion decoration. But the DF-26 is still a missile. The next system on our list is nothing like a missile. It is hundreds of small, cheap, and relentless machines that do not need a pilot. Number 3. AI drone swarms. This is the point where the conversation shifts from military hardware to something out of a movie. In 2026, China demonstrated that a single soldier in the People's Liberation Army, holding one controller, can direct a swarm of more than 200 armed drones at the same time. 200 individual attack drones, one operator. sitting at a safe distance from any fighting. These drones are not built for reconnaissance. They do not circle overhead and beam back video. They are one-way attack platforms. Each drone flies to a target and detonates on impact. They are inexpensive to manufacture, fast to deploy, and packed with processing power. Think of them as airborne robots that serve a single function. They do not return to base. They do not need to. What makes this system genuinely unsettling is what happens when you try to stop it. The obvious countermeasure against drones is electronic warfare. You jam the signal between the operator and the drones. If the drones cannot receive commands, they should be harmless, right? Wrong. If the link between the soldier and the swarm is severed, the drones do not shut down. They do not drift aimlessly or crash. They switch to autonomous mode. The onboard AI takes over and continues the mission without any human input. The drones keep searching for targets and keep attacking. Imagine trying to stop a swarm of locusts by turning off the lights. The locusts do not need your lights. They have their own way of finding the crops. You cannot negotiate with a machine learning model. You cannot distract it or frighten it. It identifies a target and flies directly into it. Now think about scale. China has ordered these drones in enormous quantities. Military researchers warn that swarms numbering in the thousands could be directed at a carrier group in a single attack. A modern American destroyer carries maybe 90 to 100 interceptor missiles. Each interceptor round costs hundreds of thousands of dollars. Each drone costs a tiny fraction of that. If China sends 500 drones at a carrier group, the defender has to spend 500 interceptors to stop them. The ship does not carry that many. It runs out of ammunition before the swarm runs out of drones. This is not an engineering problem. It is an economics problem. Imagine trying to bail out a flooded basement with a coffee cup while somebody runs a fire hose into the window. Your cup works fine. The problem is that the water is coming in faster than you can remove it. Right now, the math favors China. But quantity is only half the story. The next system on this list represents the other half. Number 2. The YJ-21. The YJ-21 is what happens when you take the concept of quality and push it to its absolute limit. This is a hypersonic anti-ship missile that launches from China's Type 055 destroyers, which are widely regarded as some of the most capable surface combatants in the world today. The YJ-21 travels at Mach 10, which means it moves at 10 times the speed of sound. To wrap your head around that speed, consider a rifle bullet. A bullet leaving a rifle barrel travels at roughly Mach 2.5. The YJ-21 is 4 times faster than that. Now imagine that instead of flying in a straight line toward a fixed point, this object is actively guiding itself toward a ship that is trying to maneuver away. That is what the YJ-21 does. At Mach 10, the time between when a ship's radar detects the missile and when it arrives is a matter of seconds. The crew of that ship has to detect the incoming threat, classify it, decide on a response, and trigger their defensive systems, all before the missile is already on top of them. Think about how long it takes you to react when somebody tosses you a set of car keys. Now replace the keys with something moving 4 times faster than a bullet and give yourself maybe 10 seconds. Your brain recognizes the threat, your hands start to move, but the missile is already there. And the speed is not even the most dangerous feature. Like the YJ-20, the YJ-21 performs a terminal dive, coming down on its target from a near vertical angle, but it does so at Mach 10. Every close-in defense system on a modern American warship, the phalanx rotary cannons, the rolling airframe interceptors, the C-RAM launchers, was engineered to handle threats that approach at lower angles from the horizon. A warhead screaming straight down from directly overhead at 10 times the speed of sound falls outside the parameters those systems were built to handle. No U.S. defense system has been publicly demonstrated to reliably intercept a YJ-21 in a realistic engagement. China is already loading these missiles onto multiple Type 055 hulls and intends to expand the program. The most sophisticated surface fleet America has ever confronted now carries a weapon that American planners cannot confidently counter. Every system on this list so far has been about neutralizing or destroying American carriers. The number one entry is fundamentally different. It is not about destruction, it is about construction. Number 1. The Type 003 Fujian supercarrier. You might wonder why an aircraft carrier sits at the top of a list about making another navy useless. The answer is that the Fujian is not just a ship, it is a declaration. It says, China is no longer only building weapons to sink American carriers. China is building its own. In November 2025, China commissioned the Type 003 Fujian into active naval service. President Xi Jinping personally stood on the flight deck to observe the ceremony. What entered the water that day was not a refitted Soviet hull or a reverse-engineered copy. The Fujian was designed and built from the keel up in Chinese shipyards, and it carries electromagnetic catapult technology. A catapult is what makes a carrier work. Fixed-wing aircraft need significant speed to generate lift, and a carrier runway is only about 300 meters long. A catapult grabs the front landing gear of a jet and accelerates it to flying speed in less than 3 seconds. Older carriers, including China's previous two, use steam catapults. Steam systems work, but they are violent. They slam the airframe with sudden force, which stresses the aircraft structure and limits how heavy a plane you can launch. Electromagnetic catapults use magnetic fields instead of pressurized steam. They accelerate the aircraft smoothly and precisely, which means you can launch heavier planes more often with less damage to the airframes over time. This electromagnetic system exists on only one other carrier anywhere in the world, the USS Gerald R. Ford, America's most advanced supercarrier. The United States spent decades and tens of billions of dollars developing this technology, fighting through years of delays and cost overruns. China observed that entire process, learned from it, and then built its own version from scratch. The Fujian displaces 80,000 tons, placing it among the largest warships ever constructed in Asia. Its air wing includes the J-15T, an upgraded multi-role fighter, and the J-35, a stealth aircraft designed to compete with the American F-35. The electromagnetic catapults allow the Fujian to launch these heavier, more capable aircraft with greater frequency and precision than anything China has operated before. And China now has 3 carriers in active service. The United States operates 11. But China is building more, and the pace of construction is something the U.S. Navy has publicly acknowledged it cannot replicate. Chinese shipyards are turning out hulls at a rate that some defense analysts compare to American production during World War II, when U.S. yards produced ships faster than anyone could track them. China is now approaching that level of output. The Fujian holds the number 1 spot, not because it is the most destructive system on this list. The DF-27 is more dangerous. The carrier killers are more immediately threatening. But the Fujian represents something that none of those weapons can match. It marks the point where China stopped being a nation that only tried to neutralize American carriers and became a nation that operates carriers of its own. For 30 years, Chinese strategy was reactive. Build weapons to keep the other guy away. Make his tools useless. Push him back from your coastline. The Fujian changes that logic. It says China can now project power across the ocean, the same way America has for 7 decades. It is not defense anymore. It is offense. That shift rewrites the rules for any future crisis in the Pacific. The United States Navy remains the most experienced and battle-tested maritime force on the planet, and it is not standing still. It is developing directed energy weapons, longer-range unmanned systems, improved interceptors, and new operational concepts built around the reality that carriers cannot operate close to an adversary's shore anymore. But the world of 1996, when two American carrier groups could cruise the Taiwan Strait without consequence, is over. China devoted 30 years to building missiles, drones, ships, and hypersonic systems with one singular purpose. And based on this list, that purpose has been achieved. If this gave you a perspective on the Pacific that you were not hearing elsewhere, please hit the like button, subscribe, and turn on notifications so you never miss the next video. There are related videos on the screen right now if you want to keep going. So here is something to think about. Will these new systems actually reshape the next conflict, or will new defenses eventually close the gap? Drop your thoughts in the comments.